All right, good morning, Math 8. We are starting our final unit today of the year, and hopefully it's not a bad one. It's very graph-centered, very data-centered, and there should be a lot of realistic context here. There's a lot of places we could incorporate some nice projects to finish out the year, some nice data gathering if we have time for it. I don't know if we will, but we'll just see. Hopefully it's not a too crazy place to end the year. So let's get started. The format's slightly different. I'll be sharing this slide presentation with you later with my notes on it, and whichever class I see live, which I don't actually know who it is at the moment, we'll just go through pretty much the same thing. So those of you seeing it live versus the video are not going to be having any sort of a different class. Okay, so let's go to the next slide. And also let me know if the video at any point is hard to see, because since it is on Google Slides and just based on the content, there's going to be a lot of graphs, scatter plots with points on it. If you ever can't see anything, just let me know if you need a better shot of anything. If no one tells me, I'm just going to keep doing stuff like this, and it's not going to change. So if it's hard to see, tell me now, because we got 3 more weeks of this stuff. Okay, so our first part of this is just making sure we understand what we're looking at when we see a graph. So if I'm looking at the graph about this cute little panda right here, I've got a panda that lives in a zoo, because most of them do. What does the point on the graph tell me about this panda? So I want to look at this graph and really see what is the purpose of this graph. What is it telling me? So when I look at this graph, I want to make sure I read first, not just the numbers. I don't want to jump to this 3682 first. I want to really understand what's being measured on my graph. So the first thing I notice is that my x-axis is talking about the age of that panda in months. How old is this panda bear? And then my y-axis is telling me the weight of this panda in kilograms. So really, my graph's goal is sort of to see if there's a relationship. The whole unit is comparing 2 different quantities. Is there a relationship between these 2 quantities? So is there a relationship between the age of the panda and its weight? So this panda bear here, the point 3682, that point really represents a panda. There is a panda that this point applies to. And then that panda, the 36, the x value, is the age. So it's 36 months old, or 3 years old. And the 82 is my y value. It really should be a bit higher, but that's okay. That 82 is the panda bear's weight in kilograms. So that 36-month-old panda weighs 82 kilograms. All right, so we are going to be focusing on a lot about what points tell us on graphs. By the way, my wife told me I say "all right" way too much in these videos, so I'm going to cut back on that, because she hears me do these live, and she laughs at me every time I say that. So I'm going to try to not say that as much. So let me know if I succeed in that too. Okay, I almost said it again. Next slide is going to start really getting more detailed. So again, this is one especially where if you can't see what I'm doing, let me know, and I can try to get you a better screenshot of this. But also, you will have this same exact slideshow shared with you, where you can either, I'll probably give you a view-only version that you can make a copy of, so that way you can do all your own stuff on it. So, which point in the scatter plot represents car L's measurements? So where's car L? Well, here, okay, so I've got the scatter plot, and it's measuring weight, and it's measuring fuel efficiency. So how heavy is this car, and what's its mileage like? Fuel efficiency is basically miles per gallon. How far can I go on a gallon of gas? I'm sure you've heard people talking about fuel efficiency of their cars. Little cars good, big cars not so good. Hybrids, very good. Stuff like that. And there's a relationship possibly between how heavy a car is versus its fuel efficiency. But more on that later. So car L, if I look in my table, which is hopefully not that blurry for you, I see that car L weighs 1,663 kilograms and 19 fuel efficiency, so 19 miles per gallon. So, all right, it's not phenomenal, but it's like my cube. So you'll notice that your graph counts by 250. So you're not going to get exactly perfect points. And luckily, since we're not in school, I'm not really going to have you plotting that many points on graphs, so you've really dodged a bullet there. So I'm going to look on my graph, and where do I see 16, 63, and 19? And I'm actually going to start with a y value here, because my fuel efficiency of 19 is right in between 18 and 20. And let's see, this point here, right here, that's between 1500 and 1750. And I'm looking for 1,600, which would go right around here. So car L is actually going to be that point right there. I'm going to put the box around it. So it's the point with the box. That is car L. All right, it's a good thing it's on the very edge of my graph, or there's no way it would work. So car L is that point right there, that little dot right there, because it's 19 miles per gallon and it weighs 1,663 kilograms. Okay, so that's car L. So what is the fuel efficiency of the car with the greatest weight? So greatest weight is going to be, and I'll type in red so you know it's new. So greatest weight is going to be farthest right, or highest X value. So the fuel efficiency of the car with the greatest weight, that would be this one right here. That's okay. I gotta make that transparent now. How do I do that? Now you get to watch me figure out how to use Google Slides. Isn't that just awesome? Change the shape? No. Format options? Promising. Oh dear. Oh no. Curses. How do I make this shape? Oh, fill color. There we go. Transparent. Got it. Okay. So that was for question 2. Took way too long. So that's my answer to number 2. So I'm going to add some text to that. So that's our point we chose from number 2. Okay, so that point had the highest, so that's the fuel efficiency of the car with the greatest weight. And that fuel efficiency, that's the car with the greatest weight right there. And the fuel efficiency of that car is 16 miles per gallon. So that's the answer. The fuel efficiency is 16 miles per gallon, and that's the point I used for number 2. Okay, so I'm going to copy this so I can use this for the next question. So what is the weight of the car with the greatest fuel efficiencies? Which car gets the best mileage? And that car is going to be the highest up on my y-axis. So I'm going to paste that little blob. I'm going to change it to number 3. And then I'm going to scoot that little blob right over here to my highest point, my highest fuel efficiency. Oh no, grabbed the wrong thing. Okay, there's that. So that's the point for number 3. So the greatest fuel efficiency, I'm going to type in red again. I'm good at that. The greatest fuel efficiency is going to be the highest up, which is also the largest y value, because efficiency gets measured on my y-axis. Okay, so my answer to that is going to be, let's see, it's a little bit to the left of 1250. So I would even just say just under 1250 kilograms, and if you want an actual answer, you could say like, I don't know, 1240 kilograms. And a lot of this unit, you're going to be dealing with not quite the number. Like, it's not quite 1250. It's like 1240. So approximate guesses, I'm very lenient with that, as long as it makes sense. If you said 1,000, you'd be incorrect. And if you said anything more than 1250, you'd be incorrect. But, like, just be reasonable. It's almost 1250. Even if you said, like, 1,200, that's fine. If you said 1,100, that's questionable. But, like, just approximate if you can. So 1240 kilograms approximately. And if you throw approximately in there, then I know you're not just pulling a random number out of your hat. And I know that you've recognized that it's not a perfect system. Okay, so car S. Car S weighs 1,912 kilograms. Car S is not in my table, most unfortunately. So car S weighs 1,912 kilograms and gets 16 miles per gallon. All right, so let me make a car S. there's car S. So it's number 4. It's going to be car S. That's not how you spell car. Oh dear. That's right. Okay. Car S. The font a teensy bit smaller so it actually fits. Okay, cool. There's car S. So it weighs 1912 kilograms, you get 16 miles per gallon. On the scatter plot, plot that point. Okay. Okay, I'll make a smaller one now. Hold on. Make a very small car S. Little baby car S. Okay, 1912 kilograms, 16 miles per gallon. Get 16 miles per gallon here. 1912 kilograms. See, that's like 1875. That is like exactly right there, which is right on top of that other point. Like I don't know why they did that. It's the exact same point, but whatever. So that is car S. Okay, so car S is that little hollow one right there. Sorry, this graph's getting real messy. You're fine, Rachel, don't worry about it. So that is the hollow. I'm going to write that as the hollow circle. So it's the unfilled in circle. And just to differentiate. So you go back and you see, oh yeah, it's that hollow one. Because this one right next to it, I'm pretty sure that's car F. That weighs 1,962 kilograms and gets 16 miles per gallon. They're real close together. So I think that other one next to it is F. Okay. So now you got N and O shown in the scatter plot are made by the same company. Oh, that's nice. Compare their weights and fuel efficiencies. Okay, so N and O. Does anything surprise you about these cars? I have no idea. N and O. If we look at these, it weighs 1,432 kilograms, gets 25 miles per gallon. Well, it doesn't seem surprising at the moment. And O weighs 1,987 kilograms and gets 18 miles per gallon. Okay, again, not so surprising. So looking at it from the table, I don't know about you, but I don't really see much of anything in the table. I just see a conglomeration of numbers. And if I don't see anything, I'm guessing you guys don't see much either. Like, no offense, but I don't see much resemblance. So that's sometimes why you make a graph, is to see if you notice anything from your table. I'm sorry, if you notice anything about your data from the graph. Oh geez, wrong one. Okay, stop it. So I'm going to look and see if I can find N and O on my graph. So let's see, 25 miles per gallon is right. There's this one here, 25 miles per gallon at 1,432 kilograms. That's like right here. That does not seem out of place at all. Car O, 1,987 gets 18 miles per gallon. Let's see, 1,987 is almost 2,000, gets 18 miles per gallon. Okay, this must be a trick question, because these points totally seem to fit my trend of data. Is this point here was N, and this point here got 18 miles per gallon, and it was 1,987 kilograms. Like, those points fit the data really well. So I don't notice anything weird. Those points really, they fit the trend. They're spot on. Like, these points are like right in the middle of the data. They fit the trend. And we're going to do a lot of seeing if our data fits the trend we're looking for it to fit. Like, that's a really important part of what we're doing. Like, seeing, is it on trend or is this off trend? Is there something off with this data? Which, if you could actually read question 6, we might be able to talk about, but it's off what you can see right now. So I'm going to go ahead and try to figure that out for you. Maybe I'll duplicate the slide and delete everything else. I'm going to do that. Awesome. So now I'm going to get rid of I'm going to get rid of 1 through 4. See, this is wonderful. Okay. So now, a different company makes cars F and G. And again, I know it doesn't say on the graph which ones are N and O and F and G. Maybe I'll just put I want to put little boxes actually, so you can just see what they are. I'm going to label N and make it as small as I can. I think N was right here. Yeah, 14 something. Yeah, that was N. And then O, it was 1987 and 18. O was right there. So N and O, they fit the pattern pretty well. And I'm going to assume F and G are not going to fit that pattern super well, because otherwise why would we be asking this question? Oh, no. Okay. So you're going to be F, and you are going to be point G. All right, F and G. Let's see. F is 1,962 and 16. All right, cool. So 16 miles per gallon weighs 1,962. That's down here. 1962. Oh, it's right next to the point we plotted before. So that's that one. So that one is down here. It's like way down low. All right, cool. And point G, 2,384 kilograms and 16 fuel efficiency. Okay. So what I noticed about F and G is that they have very, very different weights. They're different by 400 kilograms, which, if you do your math, is almost 1,000 pounds. Not quite, but it's almost 1,000 pounds. So they have, where's my red? There's my red. They have very different weights, but the same fuel efficiency. And I don't know about you, but I'm looking at this as a very straight downward trend. And what we're going to do is fit lines to this data. But I'm looking at this, and it looks like car F should be more fuel efficient, and car G seems like it should be less fuel efficient. Like car F seems to be less fuel efficient than it should be. Like maybe it's like a sedan that gets bad mileage, like my first car. And car G seems to be more fuel efficient than it should be. And I've never had a car like that, so I have no experience in that regard. All my cars have been much worse than they're supposed to be. It's like that car gets 28 miles per gallon, and then it doesn't. Like, cool, thanks. Anyway, so basically we're seeing these points that don't necessarily fit the trend. Like car F's not bad. It's not super far off the trend. But car G seems to be like, well, you'd think that a heavier car would be getting less mileage at this point based on our trend, but it looks like that's not necessarily the case. Like, so maybe our graph, I don't know, does some other stuff. So that's that one. Let's see how long this video's been going on for, because I don't want to overwhelm you too much. Let's, hold on, let me pause this for a sec. Okay, so this next graph that we're looking at has something a little bit different about it, and it should be somewhat obvious if I go back to the previous graph that we looked at, which unfortunately now is covered in other stuff. But this new graph is different, and this new graph has a line on it. So this graph has something we're going to introduce today called a trend line, and I think this is going to be on the vocabulary slide at the end of the page. Yes, so a trend line is our vocabulary word. A lot of this unit is about looking at trend lines, or a line of best fit, or a line of good fit. Because getting the line of best fit requires scary math that I don't even know how to do. So we call it a line of good fit. And if you use graphing calculators or Google Sheets can do it, it can calculate the best fit line, or if you give kids some knowledge, they can calculate good fit lines, or good enough fit lines. So it's a line that describes the overall path of the data. And what this model does is the trend line predicts. So that trend line that you're seeing is kind of like an average. It predicts the typical path that the data should follow. So you write a formula of a trend line in, remember this, slope-intercept form, where m is the slope and b is the y-intercept. And the slope and the y-intercept have important meanings about the trend line and what you can predict about your data. Okay, so there's our first vocabulary word. The second one is less important, and we might get to it later. We might not. So basically, we're going to talk about what the trend line does. And the trend line, again, it predicts some data. So our table here got a whole lot more confusing. It really didn't. So here we have diamonds, possibly, or something else that gets measured in carats, probably diamonds. And basically, the trend is with diamonds that the bigger the diamond you get, the more money it costs. And I can assure you, as someone who's bought exactly one diamond in his life, that that is exactly true. The bigger the diamond you get, the more money it costs. There's other factors that go into it too, like how shiny it is, what cut it is, whatever. There's other factors at play, how good of a diamond it is. But at the end of the day, if you get a bigger diamond, you will pay more money for it. So we have to use a bunch of data about how big a diamond is versus how much the price of that diamond was. Okay? And then that third column shows the predicted price. So basically, why do I need a predicted price? Well, basically, let's pretend you have all these diamonds from maybe went to Kay Jewelers or Michael's Jewelers in the mall, and you're looking for one, and you found all these diamonds, and then you said, "Oh wait, here's a different one I want. That's this weight," and if you have some sort of model or some sort of gauge of what you should expect to pay, you can compare your predicted price to what you actually pay. If you ever go car shopping, if you use cars.com, which I would have you do if I could give you a project on this because it's so fun, you could look at cars, and sometimes cars will say great value or good value, and sometimes they'll say nothing. And basically that's saying are you paying less than you'd be predicted for this car? Oh, typically with this car you would pay more than this, but this particular one is cheaper than expected. So basically, the predicted price is the average path. It's that middle path. There's stuff above it, and there's stuff below it. And there's about the same amount of stuff above and below. Anyway, there's questions on the next page. They didn't fit, and also you want to be able to see the graph big. So let's cover these questions, and we'll move on to our exit flip. So let's see. Oh dear. The scatter plot shows the prices and weights of the 20 diamonds together with the graph of this line. So that's an equation of the line. Don't be scared by it. It's okay. There's a slope of 5,520 and a y-intercept of 1,091. So the function described by the equation is a model. This equation is a model in that it represents the data. It represents the relationship between a diamond's weight and a diamond's price. And the model is used to predict how much a diamond will cost based on its weight. The important part today is recognizing that the trend line, or this model, is predictions. It's not anything real. It's no precise data points. It is an approximation. It's like an average. It's like a predicted thing. All right. So two diamonds that both weigh 1.5 carats have different prices. So what are their prices, and how do I see it in the table in the graph? So if I'm looking at question 1, both diamonds weigh 1.5 carats. So that would be right here. That's this table right here. And these two 1.5 carat diamonds, one of them costs $7,474, and one of them costs $5,904. And before you go buying the cheaper one, you got to recognize, all right, those same size diamonds, that bigger one might be a little bit shinier. It might just sparkle more, or it might be a different shape that's more desirable. But notice those two diamonds, the same weight, they will have the same predicted price, because we're just predicting predicting the price based on the weight. You notice all the 1 carat diamonds up here all have the same predicted price over here. Even though their actual prices vary by upwards of $1,600, the predicted price is going to be the same because, again, it's the average. It's the middle of the road up here. Okay? So that's kind of where we're at. We're looking at, all right, the trend line predicts. And just today we're really just getting our feet wet. Trend line's predicting. It's just showing us what we expect to see. And the actual price is an actual diamond. So each of these dots is an actual diamond in real life. Maybe, at some point. It was an actual diamond they got a data point from. So you could figure out how many diamonds they actually looked at by counting all the dots, or counting the entries in the table, because each table is its own diamond. Okay, let's see. So the model predicts that when the weight is 1.5 carats, the price will be $7,189. Where do I see it in the graph, and where do I see it using the equation? So in the equation, I could do, and I'll do this in red, I could do y equals 5,520x minus 1,091. And I could see that by letting x be 1.5 for 1.5 carats. And then I do the math. So I could say y equals 5520. And of course you have a calculator, you have a computer. And I just do the math. And I can check the table to see what I'm going to get as my answer, because my answer is going to be $7,189. So y equals 7,000, I already forgot the number. It's been a long day. $7,189. Oh, geez. That's my predicted price. Okay, and I see it on the graph. This is where the solid line is over 1.5 on the x-axis. So if I look at my graph, I can see 1.5 right here. That line is at exactly 7,189. And obviously, if you didn't have the table, you wouldn't know that exact number. But you can see it's like, all right, it's definitely less than half. It is way under half. That point right there is about about 7,500. And this point here is like, I'd probably guess it's at 7,250 to be honest. But it's 7,189 according to my model. Okay? So, yeah, that's that question. And honestly, I think we could even just skip the last couple. You could try these ones. Let me just double check the Google form to see what you got to do for today. Yeah, let's do that last two. Why not? If you're bold enough to try it without, you don't have to join me. Oh, dang it, that's my attendance for last meet. Hold on. Okay. Okay, so one of the diamonds weighs 1.9 carats. What does the model predict for its price, and how does that compare to the actual price? So I can look at a couple different places for this. I'm going to look at the table, though. So table, 1.9, the actual price was 9,541, and predicted was 9,379. So I got to remember those numbers. Actual, 9,541. Predicted, 9,003. None of those are numbers. 9,397. And how does that compare to the actual price? Well, the predicted is less than the actual price by, all right, sorry. 3 more gets me to 9,400. So 3. I need 100 more to 500. So 103. Then I need 41 more. So 144. $144. That's how you're taught to subtract now, right? Just by adding it back in. Such a good method to mentally subtract. I love that. And then, yeah, that's it. We conveniently had the table to tell us our numbers. So that's good. And find a diamond for which the model makes a very good prediction. So I'm actually going to duplicate this page as well because these last two questions are not going to fit. So which diamond does the model make a very good prediction? So I'm going to look at the table for two prices that are very close for the same diamond. And then I'm going to do the same thing on the graph. So I'm going to look at the graph. I'm actually looking at the graph first, to be honest. Look at the graph for a point very close to / on the line. So we're going to look at that on the graph. So I'm going to go back here. And, this one right here. Do this one right here. Okay, so that's cost about 5,500. And it's going to be about 1.2 carats. So this one right here. So that 1.2 carats. Actual price is $55.44. Predicted is $55.33. The predicted is only $11 less. And in terms of diamonds, that is spot on. That's like a quarter of what tax, like a tenth of what tax would be. So I'm going to go to, let's see, 1.5, no, 1.2. So let's see. The 1.2 carat diamond costs $55.44, and it was predicted to cost $55.33. So it's only off by $11. And honestly, I think looking at the graph is more efficient than looking at the table first. So, find a diamond for which the model's prediction is not very close to the actual price. How can you see it in the table, and how do you see it in the graph? Well, I'm going to look at the table for 2 points. So instead of looking for, did I not copy everything? Look for the two prices that are very far apart. Oh dear, far apart for the same diamond. And look at the graph for a point that is very far from the line. Maybe this would be like a video for 2 different days worth of lessons, and you could just do 2 different days of stuff on this. This is a very long video. If you're still watching, props to you. So we are going to go look at our graph and say, okay, this point here is pretty far from the line. And by far, I'm looking for like up and down distance from the line, because that's saying the 1.5 carat diamond, its actual price was over $1,000 off from its prediction. So I'm going to say that one. You could have also said like this one or this one or this one or this one. Those are the best ones, I think. I'm going to go with the 1.5 carat that costs just under $6 grand. So I'm going to go with the 5904 1.5 carat diamond. And I know that I picked that one because it's far vertically from the line. And we're going to include the word vertically from the line. Like horizontally, like doesn't, it's similar, but doesn't really matter as much. So the 1.5 carat that is predicted to, that costs, I already forgot, 5904, 7189. Is predicted to cost $71.89, which is, let's see, that's $1,285. So it's predicted way more. Like that diamond was predicted to cost way more. It's really quite a bargain diamond, which who knows, for better or for worse. Who knows why it's a bargain? Okay. So the last sort of thing we talk about, which you might as well talk about since we're here, is points that are very far from the data. So which data point here does not fit the data at all? And the point that does not fit the data at all is that very bottom one over here. Like that point is very far from the regular data. That foot length does not correspond at all to that foot width. So this foot is way less wide than it should be. It's a skinny foot, apparently, a long skinny foot. For whatever reason, that person's foot is just narrow. Okay? So that point is called an outlier. So an outlier is a point that is far from the rest of the data and does not follow the prediction of the trend line. So just a point far from the data. So we talked about what a model does that predicts data. It's the line itself. It's the prediction. The dots are the actual data. And they tell you various 2 quantities about an item. And you can see in a graph, like if those 2 quantities, weight and price, or age and weight, are related in some way from the graph. Okay? Your form today is quite short. 5 questions, 5 points. At most. I don't even know if it might not even be that many. Okay? So best of luck, and thank you for staying tuned.